Hey guys, welcome to College Algebra. In this lesson, we're going to review. The first three lessons are all about review. Okay, and so this first lesson, we're going to talk about radical and rational exponents. So when dealing with square roots, if you have b squared, the square root of that, if b squared equals a, then b is the square root of a. So if 3 squared is 9, then 9 is the square root of 3 is the square root of 9. All right. Also, if you have a variable under the radical, so like here we have the square root of a squared. Well, if a is a variable and not something we actually know, then we have to do absolute values because it always produces a positive value. All right, so let's get into this. So the square root of 64 is 8. The square root of 49 is 7, but because that negative is on the outside, my answer is going to be negative 7. Okay. Let's see. When you take the square root of when you take the square root of a fraction, you take the square root of the top and the bottom. So this is going to be the square root of 1 is 1. The square root of 4 is 2. So my answer is going to be 1/2. On number 4, 4 and 5 are similar, but when they're both inside together, I'm going to add first. So you're going to be square root of 25. All right, so that's going to be the square root of 25 is 5. All right, and then on number 5, the square root of 9 is 3. The square root of 16 is 4. So 3 plus 4 is 7. So you notice how they're very similar, but you get two different answers. So be careful with that. On number 6, you got 6 squared. 6 squared is 36. And then the answer, the square root of 36 is 6. Okay? And then on 7, once again, that negative is taken care of. So that's the square root of 36. And so my answer is 6. Okay. 8, we can simplify radicals. All right, so if we want to, we know that 500 is not a perfect square, but there's a perfect square that lives inside of it. All right, so we have, I can separate the 500 into 105. All right, so 100 times 5 gives me 500, and then I can separate this and say the square root of 100 times the square root of 5. Well, I know what the square root of 100 is. It's 10, so that's going to be 10 square root of 5. And so if you use your calculator and type in square root of 500, and you also type in 10 square root of 5, you get the same decimal. So these two are the same, but one's simplified and one's not. And so if you can't simplify a radical, you need to simplify a radical. On number 9, we're going to multiply first. And so that's going to be 18x squared. All right, I'm going to separate what I know to be a perfect squared. So I know that 9 is a perfect squared, and I know that x squared is a perfect squared. All right, 9 times what is 18? Well, that's 2. And so I can separate that. 9x squared, square root of 2. All right, and then I can take the square root of the 9x squared. And so the square root of 9 is 3. The square root of x squared is x. And so I got 3x square root of 2 as my answer. Okay, once again, you take the square root. You take the square root of, when you take the square root of a fraction, you take the square root of the top and bottom. The square root of 100 is 10. The square root of 9 is 3. And so 10/3 is my answer here. All right, number 11. On 10, the fraction was all together under the radical. On 11, it's separated, but the properties of radicals say that if I'm dividing radicals, I can put them together. So that's what I'm going to do first. I'm going to say 48x cubed over 6x, and I'm going to simplify that. That's going to give me 8x squared, and I can separate that into 4x squared and 2. Okay, and that's going to give me 2x square root of 2. Okay. Now, on 12, when you're adding and subtracting radicals, it's very much like fractions. You can't add and subtract fractions unless you have common denominators. And if you don't, you got to make it so. So here, on 12, I got 7 radical 2, 5 radical 2. You can almost treat this like x, like 7x and 5x. So this is going to be 12 radical 2. On 13, you have 5x and 5x. So you have one square root of 5x and minus 7 square root of 5x. So 1 minus 7 is negative 6. So you got negative 6 square root of 5x. On 14, 1 square root of 3 and 1 square root of 12. So I need to simplify, and that's where the previous steps, the previous problems where we simplified, come into play. So I need to simplify this. So that 7 square root of 3 plus, that's going to be 4 times 3. So that's going to be 7 square root of 3 plus 2 radical 3. Now I have simplified radicals. I have the same radical, and so 7 plus 2 is 9. So it's 9 radical 3. Okay, 15. I need to simplify both the 50 and the 32. So I got 4 times 25 times 2x minus 6 times 16 times 2x. All right, so the square root of 25 is 5, so I got 4 times 5 square root of 2x minus 6. Square root of 4, or square root of 16 is 4, so I got 4 square root of 2x. And then whatever's outside gets multiplied together. So you got 4 times 5 and 6 times 4, so I got 20 square root of 2x minus 24 square root of 2x. Negative 4. 20 minus 4, 24 is negative 4 square root of 2x. Okay, so there's that. Rationalizing your denominator. So I can't have radicals in the bottom of my fractions. So I multiply to get rid of that. And so a lot of times you're just going to multiply by what's in the radical, or what it is. So square root of 6 times square root of 6 is going to get rid of the square root. And so that ends up with 15 square root of 6 times, or over 6. And then, of course, you're going to simplify that. 15 over 6 reduces to 5 over 2. So you get 5 square root of 6 over 2. All right. Now, 8 is not a perfect squared, but 16 is. And so I don't need to multiply by a whole square root of 8. I can just multiply by a square root of 2. So you're going to multiply by what gives you a perfect square under the radical. On the first one, 16, I multiplied by square root of 6 because 6 times 6 is a perfect squared. All right, I only need to multiply by 2 on the second one because 8 times 2 is 16, and 16 is a perfect squared. Okay, so you got 12 square root of 2 over the square root of 16 is, so I got square root of 16, and so that's going to give me 12 square root of 2 over 4, and that reduces to 3 square root of 2. All right. On 18, I'm going to multiply by the square root of 3 on top and the bottom. And I'll do that because I'm essentially multiplying by 1. And when you multiply anything by 1, it's itself. So you got 5 square root of 3 over 3. And there's nothing left to do. You can't simplify that any further. So that's my answer. On 19, 12 is not a perfect squared. 24 is not a perfect square, but 36 is. So I just need to multiply by square root of 3. All right, so that's going to give me 6 square root of 3 over square root of 36. All right, so that's going to give me 6 square root of 3 over 6. So it's just going to give me square root of 3 when all is said and done. All right. Now, what if you got something in the bottom that is a binomial? So here we have 5 plus square root of 3. And so what we're going to do is we're going to multiply by the conjugate. So up here, if it's a plus b, I'm going to multiply by a minus b, and what that results in is a minus b at the end, which means I'm going to end up with a real number. So I get rid of all my radicals that way. 5 minus square root of 3, 5 minus square root of 3. And as you can see, I square the first term, I square the last term, and subtract. So this is going to be 7 times 5 minus square root of 3 on top over 25 minus 3 on the bottom. So that's going to be 7. 7 times 5 is 35 minus 7 square root of 3 over 22. All right, so there you go. That's how you do that. And then 21, same thing, but this time I'm going to multiply by 4 minus square root of 5 Okay, so that's going to give me 8 times 4 minus square root of 5 on the top. And then it's going to give me 4 times 4 is 16 minus 5. All right, so it's going to get 4 times 8 is 32 minus 8 square root of 5 over 11. There you go. All right, we don't just deal with square roots, we deal with higher roots as well. So we will work with other types of roots in this class, and they're defined the same way. However, if the root is odd, I can have a negative inside. If the root is even, I can't have a negative inside. Okay, so the cube root of 24. I could simplify this the same way I did earlier, but instead of looking for a perfect square underneath, I'm looking for a perfect cubed. And so this would be the cube root of 8 times 3, because 8 is a perfect cubed. Okay, so that would be the cube root of 8 times the cube root of 3. And so the cube root of 8 is 2 times the cube root of 3. Okay, 23. I need to multiply these together first. All right, so on 23, we're going to multiply these first, and we're going to get 4, the fourth root of 32. All right, so I need to separate this and simplify. 16 is a fourth root, so 16 times 2, and that's going to give me 4 square root of 16, or fourth root of 16, the fourth root of 2. All right, so it's going to give me 2 fourth root of 2. 24, we take the fourth root of the top and the bottom. Well, the fourth root of 81 is 3. The fourth root of 16 is 2. So easy peasy. Yeah, your calculator might be a good help for this. But another good help is just a lot of practice, getting familiar with this. And if you haven't already, I would highly recommend that you learn the first 15 to 20 perfect squares and the first 10 perfect cubes. And maybe you want to throw in a few fourths as well. As soon as you commit this to memory, like this becomes really simple. This becomes really simple. Okay, so on 25, I got to subtract. But before I do that, I got to simplify. So 16 is not a perfect cube, but 8 is. So you get 8 times 2 minus 11, cube root of 2. 5, cube root of 8 times cube root of 2 minus 11, cube root of 2. All right, the cube root of 8 is 2, so 5 times 2, cube root of 2 minus 11, cube root of 2. All right, so that's going to be 10, cube root of 2 minus 11, cube root of 2. And that's going to be negative 1, cube root of 2. And you don't have to write the 1. You do have to write the negative, but you don't have to write the 1. So you could say negative 1 cube root of 2, or you could say negative cube root of 2. Either one is correct. All right, 26. The cube root of 81 is not a thing. So we got cube root 27 times 3 minus 4 cube root of 3. The cube root of 27 is 3. So I got 3 times 3 is 9. So I got 9 cube root of 3 minus 4 cube root of 3. So the final answer is going to be 5 cube root of 3. 9 minus 4 is 5. So, all right, rational and negative exponents. So any root, so we've been dealing with roots and radicals this whole time. All right, any root can be written as a fraction. So if I have a to the 1 over n, that becomes the nth root of a. And if I have a numerator that's not 1, then that exponent can be written on the outside or the inside of the radical, like so. And then we also have negative exponents. So if I have a to the negative 1 over n, then I rewrite that. I can't leave, just like I can't leave radicals in the bottom of a fraction, I can't leave negative exponents in my answer. So what that does is it changes its location. So if it's at the top to begin with, I move it down and say 1 over a to the 1 over n. And if it's already in the bottom, so if like this was negative, then it would come up and it would be positive. So just keep that in mind. So 27, this is the square root of 64. That's what that means, and that is 8. On 28, I got the cube root of 125, and that is 5. On 29, I got a negative fourth root of 16. All right, the fourth root of 16 is 2, so that's going to be negative 2 as my answer. If the negative was inside, I would have a problem. But I didn't have a problem because the negative was on the outside. On 30, because of that parentheses, the negative is on the inside, but the cube, that's an odd root, and I can have a negative under an odd root. So this is going to be negative 3. Now I have a negative exponent, so this is going to be 1 over the cube root of 64. And the cube root of 64 is 4, so this is going to be 1 over 4. Okay. 32. All right, so now I have a root, I have an exponent that has a fraction that doesn't have a 1 as a numerator. So this is going to be the cube root of 27, and then I'm going to square it. All right, so the cube root of 27 is 3, so it's 3 squared, which is 9. All right, I got the square root of 9 cubed. All right, the square root of 9 is 3, so 3 cubed is 27. The fourth root of 81. All right, and the fraction is negative, so that's going to be 1 over the fourth root of 81 cubed. The fourth root of 81 is 3, so this is going to be 1 over 3 cubed, which is 1 over 27. On 35, we're going to multiply 5 times 7. So 5 times 7 is 35. And then we have x. When you multiply like bases, you add your exponents. So it's going to be 1/2 plus 3/4. And so it's going to be 35x. And you can use your calculator to help you with that, but that's going to be 5/4. And you just leave it like that. All right, on 36, we're going to divide. And so that's going to be 32 divided by 16 is 2. And because a while ago on 35, we multiplied like basis, so we added. Here we're dividing like basis, so we're going to subtract. So it's 5/3 minus 3/4. And again, you can use your calculator for help with that. But that's going to give you 2x 11 over 12. All right, reducing your index. So if I were going to rewrite this is going to be x cubed to the 1/9, which is the same thing as x to the 3/9. Well, 3/9 can reduce, and that's going to be x to the 1/3, which just means this is the cube root of x. So the ninth root of x cubed is the same thing as the cube root of x. So this is what it means to simplify your index or reduce your index. Same thing on 38. You have x cubed, and then you have 1/6. Okay, well, that's the same thing as x to the 3/6, which is the same thing as x to the 1/2, which is the same thing as square root of x. All right, guys, that is lesson 1. I'll see you in the next lesson.